Hello, my name is Robert and I am a student at the sport of the computer science career. This video is the presentation of operating system project. The XYZ electric company is developing a system for avoid collision. The system uses a laser to periodically calculate the distance to the object that is in front of the vehicle. Because the street may have bumps or obliqueness, the distance estimated is not always correct. To solve the problem, the XYZ has placed a gyroscope that reports the inclination of the vehicle x-axis. What each device is turned up is take a variable time to 1 or 2 seconds to start operation. So any date that is read before the time is incorrect. The frequency to which data are sent by both the laser and gyroscope are different. The laser is oversized as fast as gyroscope. Okay, graphically, it's like that this is a car, this is a sensor laser, and this is a gyroscope laser. The problem is to design a system that provides the best estimate of real distance to the object in the shortest time possible and without loss of sensor data. By making the corresponding question, as agreement reached that the solution should be the capacity to 1. Reconfigure the data of the gyroscope and the laser. 2. Calculate, take into account the arrival of the data and the geometry of the problem. The correct distance. 3. Start, terminate, or selective restart any of 2 sensors. And 4. And finally, measure the response time for each data generated by the related system to able to generate performance statistics between concurrent and not concurrent version of my solution. Okay, before proceeding to explain my solution, it is necessary to know what we have. Okay. First, we have a file sensor plus C, whose functionality is to simulate the data that both the laser and gyroscope generate, always taking into account the distance is generated 2 times more than the gyroscope. Each generated data is placed in a shared memory that is one store all distance and another to store all data of the gyroscope. If any process wants to access the data, it will do through an access code or key. Sharing memory uses science in the fastest way to share the data. It sequentially is the time. Let's see with a small example. If I decided to make my solution sequentially, each word looks something like that. Imagine that accessing data is 2 milliseconds and accessing your gyroscope delay 4 milliseconds. The max time to execute all is 6 milliseconds. Okay? Where if it didn't concurrent were trick, for example, I will simply take large value of the max time or execute is 4 milliseconds because the time more large is 4. Okay, there is another way to do a program concurrent, and this is process. The question is, why threads and why not process? Okay, the reasons are that it takes much less time to create a new thread in an existing process than to create a new process. It takes much less time to finish thread than the process. The threads make the communication between processes faster since sharing memory and resource. They can communicate with each other without involving OS code. Okay? As a second point, of my solution, we have to estimate the correct distance. For this, we will sure only remember a simple equation. The Pythagorean theorem simply take the distance emitted by the laser and multiply for the angles emitted by the gyroscope. The solution to be designed with threads and threads called get gyroscope and another get distance give me the ability to start, finish, and restart all of them. Okay? This is an action with session. Start, terminate, or restart. I can decide to finish the distance or the distance covered is not calculated, but it's decided to finish the gyroscope, no calculate, and after, if I decided to restart, only create a new thread. Okay, this is the facility that work with thread. Finally, it is necessary to see if the concurrent solution presents improvement with respect to the sequential solution. To prove this, I have two methods. The first is the time. It's take to read the distance, gyroscope data, and estimate the correct distance. Of 53 data analysis in the concurrent version, H value to 2 milliseconds, 32 value 3 milliseconds, and 13 value 4 milliseconds. Now, of 53 data analyzed in the sequential version, 4 value 6 milliseconds, 36 7 milliseconds, and 13 values 8 milliseconds. With this graph, we can conclude that concurrent version is practically half of what the concurrent version. Okay, the second metric is the data, quality of data. The values that stay in the range specific in this slide, the color red represents the quality of data, and the green part represents the error estimated. Okay, with two metrics, I prove that the concurrent version have improvement with respect to the sequential solution. For this reason, I say that my solution is okay, it's good for present to the company. Solution is scalable because I have to enter the 2 or more sensors. For the future, if the company push another sensor, okay, thank you.